Hello, this is my video assignment number 2, and first I'm going to be showing you, first I'm going to draw an example of a chiral compound and its enantiomer. I'm going to kind of explain the relationship as I do it. I think you can see it. I'll draw it over here. So right now I'm just drawing a Lewis structure with a Cl and an OH. And this will be Cl, this will be the OH, and it's, now I think the exact word is wedged, yes. So now this is wedged, meaning it's faced towards me. If you were to see it in like 3D, and then because this is going to be an enantiomer, this will be dashed. Oh, hold on. This is supposed to be OH. This will be dashed, and this will show you Cl. OH. And pretty much the reason why this is an enantiomer is because it changes from being wedged, 2 of them change, to dashed. And enantiomers, what it means is pretty much all of them are reversed. All the configurations are reversed when in a mirror. And that kind of just explains, that just like shows how an enantiomer would be converged from a chiral. So this would be the chiral, and this is the enantiomer. And then next is to show you a diastereomer. I don't know how to say a diastereomer. And now it's sort of the same thing, but that's why like it's kind of trippy, and it can get you. So I'll do the same thing here, where I will draw this, keep it dashed to a Cl, OH, and then this will be, keep this one like this to be a Cl, and then this one's going to be dashed for an OH. And the reason why this is a diastereomer instead of a enantiomer is because not all of them were reversed, and only the OH group was dashed and reversed, while this remains constant. And the difference between a diastereomer and an enantiomer is that this is all reversed, while only some parts of this are reversed. Okay, I think that's good. Now we can go into, I believe the next one is a meso compound. All right, yeah. So now I'm gonna draw a meso compound, and we can draw it like this. Kind of just show you, go like this, OH, H, H. We'll do CH3 instead, actually. All right, and now to really show, I'm going to reverse it over here using mirror image. All right, so now I'm going to number each compound depending on, what's the exact word? I think it depends on their like atomic numbers or whatever, or I forget the exact thing. But this one is going to be number 1. The one below here would be 2. The CH3 would be 3. And actually we'll just make the Cl, because I know the Cl is lower than the, just make the Cl. just to make it easier. I don't know if this actually matters, it's just in my head I'll make it easier. But, and then this would be 4, and you want to go clockwise here. So you would think this would be an R, but it's actually an S because we have to reverse it. So this would be an S. And then if we do this here, this would be counterclockwise. So you would assume it would be S, but it would actually be R because you have to reverse it. And pretty much what would happen here is they actually switch. So the R would be here and the S would be down here. Let me make sure I drew this right actually, because I forget. I really don't want to restart either. Hold on. I think this is right, but I don't want to be wrong. Hold on, let me check. Dang it, why isn't this working? Okay, I'm pretty sure this is right though. Wait, hold on. I have it written somewhere. Where is the S and R? Dang it. Here it is. Okay, perfect. So this is going to be so clockwise would be R, so counterclockwise is, oh wait, hold on. So that's clockwise. So actually that's gonna be, I think this would actually be an R. Yes, dang it, okay. Hold on, I screwed up. Let me restart this. So what I did wrong was I tried to look up a video and it screwed me up to explain it, but we're gonna redraw this really quick. Okay, so now what I'm gonna do is show exactly, I know we're not supposed to do it yet, but in my head I want to show you that I can actually do it. So I'm gonna show you the R and the S and pretty much explain that. But the reason why this is a meso compound is because it's exactly the same and it's a mirror image compared to an enantiomer and a diastereomer, where they're reversed, or not reversed, their formulas are switched. As you can see, these are 2-dashed compared to this that are 2-wedged, and this is 2-wedged, and this one's dashed and that one's wedged. So it's just different because this is an actual mirror image showing similarity. But what I'm gonna do is, let me label this. So this is gonna be 1, this one would be 2, this one would be 3, and this one would be 4. So this is going to be clockwise, meaning this is actually, clockwise is actually R. So this would be an R, and then this one would be 1, that's 2, 3, 4. So this is going to be counterclockwise, meaning this is an S. And then if we do it over here, this would be 1, this would be 2, that would be 3, this would be 4. So this is going to be counterclockwise, meaning it's an S, and then this one would be an R. So in the meso compound, to kind of help show, so you would think it's all similar because this is a mirror image, but actually these flip. So even though the compound itself doesn't flip, the S and the R would flip just because the mirror image flips around, and so these compounds are switched, meaning the S and the R would have to switch with it as well. But let me draw this for task 4. It's actually to show you an RS configuration using the compound. So let me draw this compound. I think you can see over here, right? Yeah. Let me angle this so I can draw correct. You should be able to. And then this C is dashed, or sorry, wedged. Hoping the audio's okay. I'm in the library right now, so I don't want to be too loud. All right, and then this one is dashed. All right. I think this is correct. Let me make sure. All right. So pretty much first what we want to do is label which have the priority. So it kind of depends on which compound, and in this, what was I gonna say? I'm blanking. Let me just write it for you, and then I'll explain why. But this OH group, I believe, yes. So this one right here, this OH group, is going to be higher than this one because it has to do with the amount of H's. So because this is an OH group, this one is just going to have the highest priority. So this one's going to be 1, which means this one is 2 because it also has an oxygen, but it's not, it doesn't have as much priority even though it has a double bond. It just doesn't have as much priority. And then the next one is this CH group here that is wedged. So then this will be 3, and then this will be the 4th. So we have to do it like this, meaning it's going to be counterclockwise. So that means that means that this compound would be, if it's, let me just make sure I'm right, if it's counterclockwise, correct. It is going to be an S compound because this shows it's counterclockwise and you want to go from 1 to the 2, and you wouldn't go this way because it would just be going 1 to 4. So you'd have to go to the 2 even though there's a 3 here. But that's just like how you draw it, and because it's counterclockwise, it's going to be an S.